Our solar system is a magnificent expanse of cosmic wonders, each planet holding its own unique story, composition, and mystery. Stretching from the warmth of the Sun to the icy reaches of the Kuiper Belt, the solar system is not just our cosmic neighborhood, it is a living record of the universe's past and a glimpse into its future. Let us embark on a journey, traveling outward from the Sun to explore the planets that call our solar system home. Each world, from the smallest and swiftest to the largest and most complex, offers a window into the processes that have shaped not only these planets, but Earth itself. At the very heart of our solar system blazes the Sun, a massive sphere of hot glowing plasma whose gravity anchors the planets in their orbits. It is the source of light and heat that sustains life on Earth and shapes the environments of all the planets that circle it. Closest to the Sun is Mercury, a small rocky planet that races around its star in just 88 Earth days. Mercury is a world of extremes. Its surface, battered by countless meteorites and marked by deep craters and towering cliffs, is reminiscent of our Moon. With virtually no atmosphere to retain heat, temperatures on Mercury swing drastically, from blistering highs of over 400 degrees Celsius during the day to bone-chilling lows below minus 170 degrees Celsius at night. Despite its proximity to the Sun, Mercury is not the hottest planet in the solar system, but it is certainly the most enigmatic. Scientists believe that deep within Mercury, a massive iron core generates a magnetic field, though it is far weaker than Earth's. Its surface, covered in silicates and metals, tells a tale of a world shaped by ancient volcanic activity and relentless impacts from space debris. Moving outward, we encounter Venus, a planet often called Earth's sister, due to its similar size and mass. Yet, beneath the thick, toxic clouds that shroud Venus, the similarities end. The atmosphere of Venus is a suffocating blanket of carbon dioxide, laced with droplets of sulfuric acid, making it the hottest planet in our system. Surface temperatures soar above 460 degrees Celsius, hot enough to melt lead. The crushing atmospheric pressure at the surface is over 90 times greater than that of Earth, equivalent to the pressure found nearly a kilometer beneath the ocean. Despite these hellish conditions, Venus is a world of haunting beauty. Its pale yellow clouds reflect sunlight, making it the brightest object in our night sky after the Moon. The surface below is a volcanic landscape scarred by immense lava plains, towering mountains, and vast, fractured plateaus. The planet rotates slowly and in the opposite direction to most other planets, a mystery that continues to intrigue astronomers. Third from the Sun is our own planet, Earth, the only world in the solar system known to support life. The blue and green hues of Earth's surface, as seen from space, reveal a world teeming with diversity. Its atmosphere, a delicate blend of nitrogen, oxygen, and trace gases, shields life from harmful radiation and moderates temperatures. Water, in all its forms, liquid, ice, and vapor, cycles continuously across the planet, sculpting landscapes and sustaining ecosystems. Earth's magnetic field, generated by a churning, molten iron core, protects the planet from solar winds and cosmic radiation. The continents drift slowly atop tectonic plates, giving rise to mountains, earthquakes, and volcanoes over millions of years. Life on Earth thrives in staggering variety, from the deepest ocean trenches to the highest mountain peaks, a testament to the planet's unique blend of physical and chemical conditions. Next comes Mars, the red planet, named for the Roman god of war. Mars has captivated human imagination for centuries, its rust-colored surface hinting at both ancient violence and the possibility of life beyond Earth. The thin atmosphere, composed mostly of carbon dioxide, offers little protection from the sun's radiation or the chill of space. Temperatures on Mars are frigid, averaging about minus 60 degrees Celsius, with dramatic swings between day and night. Yet, Mars is a planet of sublime landscapes. Towering above the plains is Olympus Mons, the largest volcano in the solar system. 3 times higher than Mount Everest. Cutting through the surface is Valles Marineris, a canyon system so vast it would stretch across the entire United States. The polar ice caps, composed of water and frozen carbon dioxide, wax and wane with the seasons, hinting at the planet's dynamic climate. Robotic explorers have revealed evidence that liquid water once flowed across the Martian surface, carving riverbeds and filling ancient lakes. Today, scientists search for signs of past or present life and dream of human footsteps on the Martian soil. Beyond Mars lies the asteroid belt, a vast region filled with rocky remnants from the early solar system. These asteroids, from tiny pebbles to the dwarf planet Ceres, are the building blocks that never coalesced into a full-fledged planet. They provide invaluable clues to the conditions and processes that prevailed during the solar system's formation. Past the asteroid belt, we enter the realm of the gas giants, beginning with Jupiter, the largest planet in the solar system. Jupiter is a colossal world, more massive than all the other planets combined. Its atmosphere, a swirling tapestry of hydrogen and helium, is home to fierce storms and colorful bands. The most famous of these tempests is the Great Red Spot, a gigantic storm that has raged for centuries, larger than the entire Earth. Jupiter's immense gravity dominates its region of space, shepherding dozens of moons and shaping the orbits of countless asteroids. Among its moons are some of the most intriguing worlds in the solar system. Europa, with its icy crust and subsurface ocean, is a prime candidate in the search for extraterrestrial life. Ganymede, the largest moon in the solar system, is even bigger than Mercury and boasts its own magnetic field. Io, closest to Jupiter, is the most volcanically active body known, its surface constantly reshaped by eruptions of molten sulfur. Callisto, battered and ancient, preserves a record of impacts stretching back billions of years. Next is Saturn, adorned by its iconic rings, which are perhaps the most beautiful and recognizable feature in the solar system. Saturn is a gas giant like Jupiter, composed mainly of hydrogen and helium, but it is less dense, so much so that it would float in water, if such a thing were possible. The rings of Saturn are made up of countless ice and rock particles, ranging in size from grains of sand to mountains, all orbiting the planet in a thin, flat disk. These rings, though vast in extent, are only a few tens of meters thick, a delicate structure shaped by the gravity of Saturn's many moons. Titan, Saturn's largest moon, is a world unto itself, with a thick nitrogen atmosphere and lakes of liquid methane and ethane. It is the only moon in the solar system with a dense atmosphere and stable liquids on its surface. Enceladus, another of Saturn's moons, hides a subsurface ocean beneath its icy shell, venting plumes of water vapor and organic molecules into space. Traveling farther, we reach Uranus, the first planet discovered with a telescope and a world of peculiarities. Uranus is an ice giant, its atmosphere rich in water, ammonia and methane ices. Methane in the upper atmosphere gives the planet its pale blue-green hue. Unlike any other planet, Uranus is tipped on its side, with its axis of rotation nearly parallel to its orbit. This extreme tilt gives rise to seasons that last more than 20 years, with each pole experiencing decades of continuous sunlight or darkness. Uranus is surrounded by a system of narrow, dark rings and at least 27 moons, many named after characters from the works of Shakespeare and Alexander Pope. The planet's cold atmosphere, with average temperatures plunging to minus 224 degrees Celsius, makes it one of the coldest places in the solar system. The origin of its extreme tilt remains a mystery, possibly the result of a colossal collision early in its history. Next on our journey is Neptune, the outermost planet, a distant blue world whipped by the fastest winds in the solar system. Neptune, like Uranus, is an ice giant with a deep atmosphere rich in hydrogen, helium and methane. The methane absorbs red light, giving Neptune its vivid, striking blue color. Despite its great distance from the Sun, Neptune's dynamic atmosphere features massive storms and powerful winds, reaching speeds of over 2,000 kilometers per hour. The Great Dark Spot, a storm system observed in the late 20th century, was as large as Earth itself. Neptune is orbited by a faint ring system and at least 14 known moons. Triton, the largest, is a frozen world with geysers of nitrogen ice erupting from beneath its surface. Triton's retrograde orbit suggests it was captured by Neptune's gravity long ago, and scientists believe it may once have been a dwarf planet in its own right. Beyond Neptune, the solar system continues into the realm of dwarf planets, comets and icy bodies. Pluto, once considered the ninth planet, now resides among the dwarf planets of the Kuiper Belt. Pluto is a tiny icy world with a heart-shaped glacier, towering mountains of water ice, and an atmosphere that freezes and falls to the ground as snow when the planet moves farther from the Sun. Its largest moon, Charon, is so massive relative to Pluto that the two bodies actually orbit a point in space between them. Alongside Pluto, other dwarf planets such as Eris, Haumea, and Makemake drift in the darkness, remnants of the ancient disk of material that once encircled the newborn Sun. The solar system is much more than its planets. It is a complex and dynamic system, a cosmic ballet of countless objects, from the tiniest dust grains to massive planets and moons. Comets, icy visitors from the distant reaches of the Oort cloud, occasionally sweep through the inner solar system, their glowing tails lighting up the night sky. Meteoroids, fragments of rock and metal, sometimes plunge through Earth's atmosphere, blazing as meteors before reaching the ground as meteorites. The formation of the solar system began more than 4.5 billion years ago, when a massive cloud of gas and dust collapsed under its own gravity. At its center, the Sun ignited, while the remaining material flattened into a spinning disk. Within this protoplanetary disk, tiny grains stuck together, forming larger clumps that grew into planetesimals, precursors to the planets. Over millions of years, collisions and accretions shaped the planets and their moons, while the leftover debris became asteroids, comets, and dwarf planets. Each planet's unique characteristics tell a story of its formation and evolution. Mercury, stripped of much of its original mantle, may have suffered a colossal impact. Venus, Earth's twin in size, took a dramatically different path, its runaway greenhouse effect transforming it into a furnace. Earth, perched at just the right distance from the Sun, developed a stable climate and abundant water, giving rise to life. Mars, once wetter and warmer, lost its atmosphere and became a frozen desert. The gas giants, too far from the Sun to retain much rocky material, gathered thick envelopes of gas and birthed complex systems of moons and rings. Uranus and Neptune, with their icy compositions and distant orbits, hint at migrations and upheavals in the solar system's distant past.